We are starting. So this is the homework. It says it's due Thursday, but today's Thursday, so it's actually due tomorrow. We slowed things down a little bit. We're just doing the odds, so we'll be starting with number 11, because yours starts with number 10, right?
No, this is how I do.
Yeah. Does yours start with number 10 right there?
Yeah.
Good. Okay, so we're going to start with number 11. Now, some of you have not had the class yet, so it's going to feel a little strange to just kind of dive right in. It's just like yesterday. You're kind of learning the lesson as we do the homework. Then when we do the lesson in your class, it's going to be kind of like review. So, can anybody that was in my first period class tell me what the rule is when the power is being raised to a power, or what I like to say is the exponent is being exponented. Yes?
Isn't that what's the deck for that one? So you multiply it?
You multiply them, yes. So we have n to the 4th power to the 8th power. Can I just show you something real quick as a review of the lesson? If n to the 4th power is being raised to the 8th power, how many times is n to the 4th being multiplied times itself? 8 times. So if I really wrote it out, I would write it like this: n to the 4th times 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 n to the 4th. Now my arm is getting tired. Times n to the 4th. How many do I have? Times n to the 4th. 1, 2, 3, 4, 5, 6, 7, 8. I did it. Now, if we were to use our rule for multiplying same bases, what would we be doing to all of these exponents? Adding them. And adding 4 8 times, we learned way back in lower elementary school that multiplication is the quick way to add them up. So what we're actually doing here is adding up these 4s 8 times. And that's why we're multiplying 4 times 8. So it's n to the 32nd power. Does that make sense?
Yeah, I called that, and then when we were talking about it, I said 32, and then I was looking like, what?
By the way, I adjusted the weekly schedule so that the open note quiz is not going to be tomorrow, it's going to be on Monday. I'm supposed to give math quizzes and tests on Fridays, but I would be squeezing it in, and I don't think you guys are ready, so we're going to make it Monday. Yeah.
I was ready for it.
I haven't even taught the rest of the lessons yet. I would have had to squeeze it in so fast and rush through everything. And if you were in my first period class, you know that we already packed in a lot of stuff. I would have had to squeeze a whole other lesson into that class. It would have been impossible. So we're going to skip 12. Let's do 13. So now we have a rational exponent, rational, rational exponent means what? A ratio as an exponent, and a ratio simply means a fraction. So a rational exponent is a fractional exponent. So that's the same thing as a fractional exponent. And we use the same rule. If the exponent is being exponented, what do we do, Abby? You multiply. Very good. So what we have is 2 over 5 times what? 10 over 1, which is what?
4. Because that's the 10 and 5 cancel.
Yep, because the 10 and the 5 can cancel. 10 divided by 5 is 2. 5 divided by 5 is 1. 2 times 2 is 4 over 1, which is 4. So that means we have x to the 4th power. Or I could write x to the 2 over 5th times itself 10 times and then add up all the 2 fifths.
I think we're good.
I think we're good with multiplying,
I was
right?
like, no.
See how helpful multiplying can be? All right, let's do are we ready to move to number 15, or you guys take a second?
Is it if the whole number is negative, or is it if the whole number and the exponent is negative, or if it's just one? that you put it in the bottom.
If the exponent. If the base is negative,
Yeah.
that has no bearing on whether it needs to be moved or not. It's only if the exponent has a negative attitude. All right, number 15. The exponent is being exponented. Again, that's just my silly way of saying it. It's really a power being raised to a power. So what do we do with our exponents? Multiply them. What's 3/5 times negative 1/2?
I thought 3/10.
3/10. Well, 3/5 times negative 1/2.
Negative.
Good. So we have negative 3/10. So we have x to the negative 3/10. Are we done? What do we do next? Send it downstairs to the basement, to the dungeon, so it can get a more positive attitude. I know it looks weird because we've got fractions inside of fractions. What if we had fractions inside of fractions inside of fractions?
No.
That'd be weird. But we won't put that in.
Ah,
Just like,
Yeah.
you need to write down a list of who was on your pencil, because in first grade you forgot.
I know, I forgot. Number 17. Oh, I like this one. Why do I like this one?
Because
What
it's
if
hard.
you cross out z to the 8th power because it has a 0?
Yeah, because this is being raised to the 0 power. That just means that this is 1.
So it's gone.
Yep.
And then you just have your answer now.
Z to the 1/2 power.
We should have no problems with that.
Yeah, I know. I love when things are raised to the 0 power. It's amazing. Ready for 19? Oh, another one! Look! D to the 3rd to the 0 power. Bye-bye! Now I cross it out and say bye-bye. Technically it has a value of 1,
Yeah.
but that 1 is just being multiplied by this, so we're just going to end up with this. If everything gets wiped out, we would actually have to write the 1. But now we have c to the 3rd to the 1/9. What do we do with our exponents? Multiply them. So I'm going to put 3/1 times 1/9 because anytime we have a whole number being multiplied by a fraction or vice versa, we want to just put everything into fraction form. So that would be what? 3/9, which is what?
Wait. Wait.
We can cancel,
Yeah,
right?
so it'd be 3.
Yep, 1/3. Are we done? Yes, we are. That was a trick question. Usually when I say, are we done? The answer is no. You guys didn't fall for my trick. Right, number 21. I pressed record, right? Yeah, I did. Okay. Number 21. Oh, we got a lot going on in here. So we have m to the 3rd being raised to the -1 power. What do we do? Multiply. So what would that be? M to the -3. We will have to take care of that negative attitude, but let's just continue on and then we'll simplify it all together, okay? So x to the 1/3 to the 1/4. What do we do with the exponents? Multiply 1/3 times 1/4 equals what? 1/12. So that's x to the 1/12 power. One last step would be what? Yep, sending this guy, the m to the -3, to the basement, or the dungeon. So that would be m to the +3. And in our numerator, x to the 1/12 can stay where it is. Is this looking a little crazy? Yeah.
I know.
Did it yesterday when we did the homework first? Did it feel a little crazy, and then when you had the lesson, it felt a little less crazy?
I mean, I just understood that.
You did. It's getting a little bit more complicated because when we add a rule, we're using it, and then we're also using other rules like setting things in the basement. And then you'll see in a minute that it's going to get a little bit more complicated after this. We'll be using many of the rules.
Do we only have to do the top?
No, we're doing the whole thing. Oh, I know, I'm so mean making you practice things. Practice makes
Perfect.
progress.
Progress.
I think we're making this Actually, I put it done.
All right, I'm going to erase this so I can scroll down to the bottom. I should make a sign for next year, like my classroom where it just says practice makes progress. Don't you think that would be a good little like banner?
Yeah.
I wonder if like somebody already like made one, it's on Amazon, and I could just order it. Whoa, that's a lot of questions. Who made this?
Why would you order it if you make them?
Because I don't know how to make a poster. Oh, you mean like draw it myself? Wouldn't it be fun in like an end of the year project, like a class project, where you do like practice makes progress in big letters, and like inside the letters you have like math equations, like just like decorating them?
Sure.
That'd be cool.
Why would that
Like I give each class period like a couple of letters.
do more math.
Wait, after the EOC, does that mean like no more math?
That'd be nice, right? We'll talk about it when we get here. All right, number 23. Okay, new concept, new rule. Brand new to the people who didn't have my class yet. Ricky, can you explain what to do when everything inside these parentheses is to the power?
Oh, I think you could put the power to both of them.
Yes, the power belongs to both of them. Before we raise 7 to the negative 2 and a to the negative 2, what we can do is use our negative exponent rule to throw everything to the dungeon to get a more positive attitude, and then we can apply it again. So we're going to keep the 7a in parentheses when we put it in the dungeon and raise it to the positive 2 power, or the positive square. So we're going to keep this in parentheses because, as Ricky just said, when it's in parentheses, the exponent belongs to the 7 and it belongs to the a. I'm going to do a little side note over here. 7a squared means 7a times 7a. What's 7 times 7? 49. What's a times a? What's a times a? A squared. Yeah, a squared. Okay, so do you see how when the exponent applies to everything, that means everything is being multiplied times itself, so the 7 is actually going to change, right? The easy way to do it, the shortcut way, is to simply say, well, that's 7 squared times a squared. And then you would just do 7 squared is 49, and then a squared.
Wouldn't it be negative times 2 is negative?
Oh, I'm going to use this to simplify the denominator. So here, when your exponent is negative, before you apply everything to like each part of the term, you can simply use your negative exponent rule, throw it downstairs in the dungeon. Now that it's positive, apply that exponent 2 to the 7 and to the a. So I would end up with 1 over 7 squared is 49, a squared is a squared. Pretty crazy, right?
Yeah.
Okay, ready for number 25? Oh. Now, technically, we could use, let me see how we want to do this. Do we want to use our negative exponent rule first, or do we want to apply this exponent to each part of the term? Yeah, I would take care of you could technically go either way, but I think it's easier to take this negative exponent, make the whole thing go into the dungeon. Since this negative exponent affects everything in the parentheses, then everything in the parentheses has to go in the dungeon to the positive 1/2. Then we'll solve from there. Now, we have 1 over 36 to the 1/2 power and g to the 4th to the 1/2 power. What do we do with the exponents? Good. What do we get? Is this in the frame on the camera?
Nope.
Yeah, as long as the numbers are, I don't know.
Miss Lori,
Yeah.
you should make Zach answer 42.
You could totally do it, right, Zach? You remember everything I taught last year, right, Zach? All right. So guys, what do we get when we have g to the 4th to the 1/2 power? What do we do with our exponents? What do we do? Multiply them. 4 times 1/2, I can put my 4 over 1 here, times 1/2 is what?
4 over 1. I mean
4 over 2, which is, what's 4 over 2? 2.
Yeah.
Okay, am I done?
9.
Now we're using a rule that we went over yesterday to do this last step. What does 36 to the 1/2 power really mean? Yes, you are rocking these exponents, Abby. So, not 12. The square root of 36 is what? 6. So we have 1 over 6 g squared. Oh, I just realized I should be writing these down so when I go over them in class tomorrow, I actually have the answers. Because I don't have an answer key.
With you, when I can make you that too.
I appreciate that very much. Do you have time to do that? Can you write them? That would be wonderful. Thank you so
If only
much.
Jared was here. Yeah, if only Jared was here. Yeah, if only Jared was
Or,
here.
you know what I can do? I'll just, when you're done, I'll just use your paper as an answer key and then I'll just, like, cause yeah.
This is probably why I have an answer to
Oh, I see what you're saying. Okay, yeah, then just write them. Yeah, then just, yeah, then you can, yeah, that would be good. All right. Back to business. What number are we on? Number 27?
Yeah.
Number 27, we have 2y to the 7/9 power to the negative 3rd power. Oh my goodness, here we go again. What do we do first? Not quite. We have a negative exponent.
Oh.
Bad attitude.
Go to the dungeon.
Yep. What goes in the dungeon?
Double.
Everything. Very good. And since everything is going and being raised to the positive 3rd power, we need to put everything in parentheses. Now we can apply that exponent 3 to the 2 and to the y to the 7/9. So it would be 1 over 2 to the 3rd power is 2 cubed. You can use your calculator if you need to, but 2 times 2 times 2. 8, very good. So we have 8. And then what do we do with our exponents here? Yep. I'm gonna reduce, because I have 3 over 9 here, I'm gonna reduce that to 1/3. So I have 7 over 3. 8y to the 7 over 3rd power, 1 over 8y to the 7/3 power. Ready for 29?
Hold on, let me just.
Okay, I'm just gonna erase that. Oh man, this one's a doozy.
That one's ugly.
It is super ugly. I like them when they're ugly though. It's like a challenge. I wanna, because they're hard for me too. Like sometimes I look at that and I'm like, wait, what? So I like the challenge of it. I like them better than word problems. Word problems, I don't like that kind of challenge. They make me want to cry. These, I like that challenge. I can figure this out. Okay, sorry, I'm weird. All right, so everything in here is being raised to the 1/6 power. That means y squared is to the 1/6 power. I'm gonna write that out. Y squared to the 1/6 power times z to the -3rd to the 1/6 power. And I'm running out of room, so I'm just gonna kind of stop there. Actually, I'm not gonna stop there, I'm gonna keep going. Then it says y to the 3rd to the 2nd power. We can actually just go ahead and simplify that, right? Y to the what? We'll just simplify this. Y to the 6, very good. All right, so that's simplified, but I still need to work on these. Y to the 2nd to the 1/6, put it over 1 and multiply. What do we get?
1/3.
Yep, cancel, cancel. So we get y to the 1/3. And then z to the -3 to the 1/6, what do we do? Multiply, so we have -3/6, which is
-1/2.
-1/2, good. And then we have our y to the 6th. There are two things we need to take care of. What's one of them? Same basis?
Yeah.
Yep, same basis. What do we do with the exponents? Add them, very good. So same bases that are being multiplied, we add our exponents. So we have a 1/3 and a 6. So 1/3 plus the whole number 6, which I'll put over 1, just get common denominators, times 3 is 18. So we have 19 over 3. Are you guys with me on that?
Yep.
All right, so y to the 1/3 times y to the 6th is y to the 19 over 3. And then we have z to the -½ power. What do we do? Z to the -½ power. Put it in the basement. So it's going to go underneath here. Z to the +½ power. Cray, right?
So that's it.
That's it. Try to walk around. All right. So that was 29. Now we're on 31. Oh my gosh, look at this one. Oh, good news, good news. No negatives.
Yeah, also, can we skip it?
Can we skip it? No.
I'm
I'm gonna make it bigger. Oh, I can't. That's bigger. Yeah.
Do we have to do the complete each question part after 42? Because it's like, I don't think you guys went over this.
We actually didn't, but we'll go over it together. Yeah, I don't think there was an example on that last time. Okay, so a lot of mumbo jumbo here. Let's take a look. What should be the very first thing we do? Are you okay? Okay.
Okay. And which one?
In this one, what should be the very first thing we do?
Parentheses. J and 11.
I love how everybody says parentheses because we know that parentheses P is the first thing a PEM does. Technically there are parentheses, but is there anything inside the parentheses that can be simplified? No. So if everything inside the parentheses is as simple as it can be, parentheses is already done. So next is exponents. And yes, we see exponents here, but they're as simple as they can be. Here is where the exponent can get simplified, right? So what does this 3 belong to? Everything in the parentheses. It belongs to the 2 and to the j to the 11. So 2 cubed is 2 cubed is 8. J to the 11th cubed is
33.
j to the 33. Okay, so I took care of that. Now I'm just going to bring everything else down. 4j squared, k to the 6th, I have this, and then I have k to the 5th. What's the next thing I can take care of? We won't call them like terms because it's a little bit different. Same basis, but I totally understand what you're saying. I'm gonna kind of pull something out and simplify to that. I'm gonna pull something out first. What's the easy thing to pull out and simplify?
Letters.
Numbers. Our coefficients. It's all involved in the multiplication. So we can do 4 times 8, right? So our first part of the term will be 32. And that takes care of our 4 and our 8. What should we do next? Should we take care of the j's or the k's? JK. JK. What should we take care of, J or K? How do we know?
Both of them.
Well, we need to take care of both of them. Which one do we do first? How do we know which one to do first? I'll give you a hint. Yes! A, B, C, D, E, F, G, H, I, J, K. That means we do J first, then K next. We always do alphabetical order to keep things organized. Very good, Abs. Okay, so J squared times J to the 33, what's that? J to the 35. J to the 35. Done and done. Now I have my K's. K to the 6th, K to the 5th, K to the 11th. Am I done? Yes. It's as simple as it can get. I mean, I wouldn't call anything about this lesson simple, but this is as simplified as it's going to be.
It's like,
Yeah.
is this normal? Ain't nobody can do that, bro.
Kind of hurts when I do it.
Yeah, that's what I'm. No, you like hear her like bang.
Oh, the cracking?
Yeah.
No, that is not normal. Probably get that checked out. Okay, number 33.
I always thought that. No, I thought
All right, are we on 33? All right. Negative exponent. Should we just go ahead and send all of this to the denominator now?
Yes.
That'd make it easier, right? This can stay in the numerator, but we'll send all of this to the denominator. 2j squared, k to the 4th. Should we keep it in parentheses? Should we keep it in parentheses?
No.
Why not?
What's the point?
Yes, because you
The-
didn't multiply it yet.
Yeah, because we didn't actually simplify it, we're just moving it to the denominator. Everything is still being raised to the 5th power. It just got a better attitude down in the basement. Think about how to be nice, okay? So, that's down in the basement. Is this okay to stay in the numerator?
Yeah.
Okay, good.
Wait, yeah.
Yeah, for now, yes, okay? So we have k, in parentheses, k to the negative 1, j to the 7 to the 6th power. We might have to adjust later, but first we're going to use our power to a power rule. How do we simplify this first, the numerator part? K to the negative 1,
K
To the six.
6 now.
so it'd be k to the negative 6, good. I'm going to leave it here for a second, I'll move it later. J to the 7th to the 6th power.
Oh, you're multiplying.
Yep.
J to the 42.
Mm-hmm. The dot on this J is confusing me. It looks like a multiplication symbol.
I write my J's like that.
That's nice. Okay, and then on the bottom we have 2 to the 5th power. What's that?
2 to the what? To the
25.
10. No, wait. Oh,
I
wait,
think it's
2 to the
32.
5th.
You can do it on your calculator.
2
No.
times 2 is 4. 4 times 8. 4 times 2 is 8. 2 times 8 is 16. 16 times 2. Yeah, I would say
32. Let's go with 32. J squared to the 5th is,
3 to the 10.
uh-huh. And k to the 4th to the 5th is,
8 to the 20.
uh-huh. Good. All right. Is there anything else? Oh. This could actually be simplified in a different way. But you haven't learned how to do division yet. So I think we're gonna leave it like that. But is there anything that can be simplified based on what we have learned already?
K and J. No, K and K, J and J.
Well, hold on a second. Now, the only thing is, by this point, you have not learned how to simplify these in terms of the lesson. So we're not gonna simplify that, but I will take my k to the negative 6 and send it down to the basement. So instead of the k to the negative 6 being up here, I'm gonna put the k to the positive 6 down here.
And then do we combine them and we get K to the 26?
Yep. So now in my numerator, I'll just erase it. In my numerator, I have j to the 42nd, and then in my denominator, I have k to the 26th. So j to the 42nd over 32, j to the 10th, k to the 26th. Could this be more complicated?
Yeah.
Tomorrow we will learn about what to do when we have same bases in a numerator and a denominator. There shall be. What's your guess about what will happen? What's your guess? What will we do with the exponents? Technically, it's dividing j to the 42nd over by j to the 10th. But what do we do with our exponents, do you think? What operation have we not done with exponents yet?
Have we not eliminated them? Divide.
What operation have we not done?
Divide.
Yeah, what else?
Subtract.
Subtract. We would subtract. We're not going to do that right now.
Wait, have we subtracted exponents?
We would subtract 42 minus 10, and then it would go in our numerator. But we're not going to do that today. We're going to leave this like that, okay? Was that 33? Okay, let's do 35. Okay, 35. We didn't do this in class, so this is going to be new to everybody. 4 times 10 squared. This is called scientific notation. Scientific notation is where you represent the value of a number with powers of 10. Yeah? You learned about it in science. Good.
But we didn't do it like this.
Okay. The short story here is that this is really just 4 times 10 squared to the 5th power. So the 4 is being raised to the 5th power, and the 10 squared is being raised to the 5th power. So what's 4 to the 5th power? Do it on your calculator.
It's 1,024.
Thank you. So we have 1,024 times 10 to the,
Seven.
Oh,
10 power.
The 7th. No.
it's okay,
10.
10th power.
I said
Okay.
10.
Now, technically this is the correct value. There's a little thing about scientific notation. When you write your answer in scientific notation, you only are allowed to have a ones place, and the rest have to be decimals. So if this is 1024, I'm actually going to take what would normally be a decimal here, if this were a whole number, right? I have to change it so that this number only has a ones place, and then the rest are decimals, which would be 1.024. Then I'm going to have to change my exponent here to represent that movement. So this number isn't 1.0024. It's really 1024. So I have to show that in my exponent. It's really supposed to be moved over 1, 2, 3 spaces to the right. 3 spaces is 3 place values, 3 positive place values. So I'm going to add 3 positive place values to my exponent, because we know that 10 to the whatever power is place values, right? So I have 1.024 times 10 to the 13th power. 1.024 times 10 to the 13th power. I am going to skip.
Did that say that's the answer?
Yeah, I'm gonna say let's not do the bottom section. Okay, I'll tell my other classes and I'll email my first period. Callie, can you spread it around to all the people in first period? And I'll email them too. We're not done, I wanna do one more problem, because there are technically 3 problems left, so you'll have to do these on your own, but I'll do number 37 really quick, okay? So, 2 to the 3rd power is what?
8.
8. And then we have times 10 to the negative 3 times 3 is, what? No, negative 3 times 3 is negative 9.
Oh.
Good. Is this in scientific notation? Does it have a ones place? Good. Nothing more than a ones place, then we're good. This is perfect. We don't have to do anything to that. Let's do number 39 real quick, okay? Just because I can, and we have a minute left and you have lunch next. Number 39, we have 6.25 to the negative 2nd power. Okay, so this is to the negative 2nd power, so what are we gonna have to do here? Actually, guys, this is gonna take too long. I'm gonna let you go. I'll tell everybody that you only have to go to number 37 on this. Only to number 37. Whew. Crazy stuff.
Here you go.
Thank you.